All right, guys, welcome to 6.3, day 1. This is the last method to solving solutions. So just as a refresher, the first way is to solve by graphing two lines and seeing where they cross. And the second way is substitution, like we did yesterday. And then this third and final way is elimination. And most people like this one the best. Okay, but it all depends on the setup, which way is most useful. Okay, so here's what you do. Step 1, make sure all the terms are lined up vertically. Sometimes you have to rearrange things to make this happen. Okay, so what I mean by that is, see how the x's are lined up, the y's are lined up, the equal signs are lined up, and the constants are lined up? Has to be like that. Then examine the coefficients. You want two of the coefficients to be exact opposites. Okay, what do I mean by opposites? 4x and negative 4x. Those would be opposites. 2y and negative 2y. Those would be opposites. So you need one of these to be opposite. Then what you do is add the two equations together. Okay? And then you solve for one variable. And then you use that value of that variable to solve for the other variable. Okay, let's actually try one. All right, so we're actually going to do this one down here. So first step, are they all lined up? X's, Y's, equal sign, constant, yes. Okay, now step 2, look for opposites. Do you guys see any opposites? It's got to be for the X or Y. See how 2x and negative 2x are opposites? Okay, we're good. Step 3, you're going to draw a line and add like terms going down. Always add. 2x plus negative 2x will cancel. That's why this is called elimination. They eliminate. 3y plus 5y is 8y, and 11 plus 13 is 24. Okay, solve for y. Very easy, divide both sides by 8, and just like that, we already have y. Okay, now we're on step 5. Plug 3 in for y and solve for x. And you guys can pick either equation. I'm going to pick the top one, and I'm going to plug 3 in for y to solve for x. So if I rewrite it, it's 2x plus 3 times y is 3 equals 11. And you just have to solve that equation now. Okay, so if we clean it up a little, 3 plus 3 is just 9. And then we just have to draw the wall and solve. So minus 9 from both sides. You guys know how to do this part. You get 2x equals 2, and then divide both sides by 2, so x equals 1. There you go. Final answer, written as an ordered pair, x comma y is 1 comma 3. How awesome is that? Okay, so let's try one. So when they're opposites, it's really easy. You just add going down, solve for one, plug it into the other. Let's try one when they're not opposites. So let's go back up to this one now. You have 2y and 2y, but they're not opposites. They're both positive. So sometimes you have to multiply by something first in order to make them be opposites. Can anybody think of something you could multiply by to make them opposite? If it's 2 and 2, what if we multiplied one of them by negative 1? Let me show you why that's a good idea. Now, when you multiply, you have to distribute it to all 3 terms. Okay, so I'm going to rewrite the problem. but I'm multiplying everything here by negative 1. So now it's negative x, negative 2y equals negative 12. The second equation, I'm going to leave it the same. Negative 3x plus 2y equals negative 12. Okay, see what just happened? Now we have opposites, negative 2 and positive 2. And now we can follow the steps along the side here. Everything's lined up. We're going to draw the line and add going down. Negative x plus negative 3x is negative 4x. The opposites eliminate. And then negative 12 plus negative 12 is negative 24. All right, super easy to solve. If we divide both sides by negative 4, we get x equals 6. And then already you're halfway done. Now take that 6 and plug it back into one of the equations. It could be one of the originals or it could be one of the new ones. Doesn't matter. I'm going to pick this original one here, this original purple, and we're going to plug in x is 6. So now it's 6 plus 2y equals 12. And then that's really easy to solve. Draw your wall. If you minus the 6 over, you get 2y equals 6. And if you divide by 2, you get y equals 3. Okay, final answer as an ordered pair, 6, 3. All right, guys, so that's elimination. Sometimes it's set up perfect with opposites. Sometimes it's not, and you need to maybe multiply by something to make opposites. If you guys are feeling good, go ahead and stop the video here. I'm going to do one more for anybody that would like to see it. Okay, let's do one more. Now, number 2, see how you already have opposites? So you can go straight to adding. But let's do number 4, where you do not have opposites. Oh, guys, and something I should say, the constant terms being opposites is not helpful. It has to be the x or the y. So I'm going to multiply the entire top by negative 1 again. And reason being, if I can make this a negative 3y, it'll cancel with a positive 3y. All right, so let's go ahead and do that. It's negative 4x, negative 3y equals negative 2. Now this one I'm going to keep the same. 5x plus 3y equals negative 2. And just like that, we already have opposites, so we're ready to add going down. Negative 4x plus 5x is 1x. Negative 3y plus 3y eliminates. And negative 2 plus negative 2 is negative 4. All right, we already got x. Now pick an equation and plug it in. I'm going to pick the second one this time. Why not? Doesn't matter. You get to pick. And I'm going to plug in negative 4 for x. All right, so we got 5 times negative 4 plus 3y equals negative 2. And we're going to solve it. 5 times negative 4 is negative 20 plus 3y equals negative 2. And then if we draw the wall, if we add the 20 over, we get 3y equals 18. And then divide by 3, y is 6. All right, so the solution is negative 4, 6. All right, nice job, guys. So that's elimination. Tomorrow, we're going to do what if it's not so easy to just pick like negative 1 to multiply by. But, all right, great job. That's elimination. Thanks for watching.